In this video, we're going to look at configuring extended ACLs. So just like your standard ACLs where you had numbered and named ACLs, you have numbered and named ACLs when looking at extended versions of an IPv4 ACL. The foundation is the same from what you learned from a standard ACL. So with the standard ACL, you did the access list, the number, the permit or deny statement. You had the source address and the wildcard mask. With an extended ACL, you have all those items, but you have a few more added to those. So if you're looking at your syntax, it is access list, and instead of the 1 to 99 like you use in standard, you're using 100 to 199. You have your permit or deny statement. You can do remark statements as well. In addition to your source address, you will have the wildcard mask, but you'll have a destination address and another wildcard mask. You will have port numbers also that you will use for the source and the destination. And then you can include things like the words established or log, and we'll look at those. This is a description of all of the items within that syntax. So we'll look at that in detail in some examples. When you apply your ACL, you do apply it the same way as you did your standard ACL. When you're looking at the protocols that you use, you'll need to understand what type of protocol you're filtering. So whether you're filtering a TCP type protocol or whether the protocol is UDP, could be ICMP. So you would need to know each of those under your protocol options. You would also need to know the keywords to use. So access list, permit, TCP, any source to any destination is what this means, equal to. So what kind of port information are you filtering? What kind of specific information? Are you filtering DNS? If so, equal to 53 would indicate DNS. Equal to 21 would indicate FTP traffic. Okay, that would be your control traffic. Your actual data traffic would be on port 20. So I would recommend that you memorize the port numbers associated with a particular service or protocol, whatever you want to call that, because these are standardized. They're used worldwide. So by learning these will help you pick out that information, because more than likely that's what you're going to see on your Cisco exam is the port numbers being used. They may not be, but you can read Telnet. So if you've memorized 23 as Telnet, then great. But if you get on the exam and all you've memorized is the word Telnet or SMTP and how to configure that and haven't memorized the port numbers, then that definitely puts you at a disadvantage concerning being able to decipher what is wrong or being able to troubleshoot an ACL. So let's look at some examples here. So access list 100 permit, any, that means any source would be the first one. The second any statement is destination, equal to 22. Okay, that would be your SSH. And then the next statement is access list 100 permit, TCP, any source to any destination, equal to 443, which would be HTTPS. You're going to apply a numbered extended IPv4 ACL. So in this example, the ACL permits HTTP and HTTPS traffic from 192.168.10.0. So that's to the whole network, all of LAN 1. You're going to allow it to be permitted anywhere. So extended ACLs can be applied, it says in various locations, but they're typically closest to the source. So with your standard ACL, you apply closest to the destination. You can apply an extended ACL closest to the source because you're filtering both on source and destination, so you have a little bit more flexibility. In this particular scenario, they applied it inbound on the G000 interface, so they applied it here. So access list 110 permit TCP 192.168 10.0, 0.0.0.255, and then instead of putting a particular address, because they're going to allow that traffic to go anywhere, you can just type any. That's the abbreviated version. Equal to www, which would be your port 80 traffic or your web traffic, and then 443 would be your secure HTTPS. Then they went into interface G000 on the router right here, and they applied it in because the traffic is coming in towards the router. Now, one of the cool features you can do with ACLs, extended ACL specifically, is use this word called established. So that's all you type at the end is established. Now, the established rule is kind of neat in a nerdy sort of way. It's kind of cool because what it does is allow traffic established within your network, say inside your network, to be able to go outside your network and return. So it doesn't allow traffic that was generated originally from outside the network to come in, but allows your traffic to go out and come back in. So if you're looking at it, when you apply this other information, so access list 120, permit TCP from anywhere inside your network, destination right here, and then the word established at the end. Okay, and then when you do your show access list command, you will see, they applied it out, and then they did their access list command, and you have 657 matches. This particular one has 1166. So again, this allows traffic that originated from inside the network to go out and then return. So that was a numbered ACL. A named ACL works a lot like it did with your standard, but of course a few more details. So in this scenario, IP access list extended no FTP access. That's the name of our extended ACL. So they're created again the same way that you did for your standard IP access list extended, and they named it surfing. It permits inside HTTP and HTTPS traffic, permit TCP, and the source and wildcard mask for the source to any. That is your web traffic, that is your secure traffic. They've created another one on browsing, permit returning traffic only. So they've used the established here. IP access group surfing in, IP access group browsing out. With your ACLs, you can have one protocol coming in and one going out per interface. So you wouldn't be able to have two ACLs applied in or two applied out, but you can have one applied in and one out, but that is the max on that. So one statement per protocol, per interface, per direction, your 3 Ps. Per interface, per protocol, per direction. So if you use in this scenario your show access list command, you can actually see the matches that were applied here. You can go in and edit these as well. So if you're using the ACE entry here, you can go in and just type node 10 and then type the correct one. So here's another example here. IP access list extended permit PC1. Permit PC1 access to the internet. Now look at all the protocols. They're allowing access for all these protocols for that device. Now, what then they're doing in the next step is deny IP 192.168.10.0 to any. So they're allowing it to do all of these things, but not anything else. So you'll want to Make sure that you're very specific when you're defining your ACLs. IP access list extended reply 1 only permit returning traffic to PC1. So they've used the establish command here. So they have a permit PC1 in and reply PC1 out. You can verify your ACLs by using your show IP interface command, your show access list command, and show run. So here we're looking at show IP interface G000, and you can see the outbound and the inbound ACL. Under your show access list, we have your access list, and you can see the ACL entries here. In your show run, they used a pipeline to just look specifically at access list information, and that's what you'll see here. Now you have a couple of extended scenarios. I would make sure you feel very comfortable with your extended access control list, because this is real world, so you're going to be using this information. You may not be writing it in the same syntax and command line entry mode. You might be using a GUI type interface to do it. You might be using it on some type of security device, but this is the foundation for your access control list and providing some security to your network. So this would be very beneficial to know, not only in your CCNA curriculum and on your exam, but in a networking and security standpoint as well.